Hello and welcome to G Fun Facts Online, the show that unpacks the science behind the world around us. When a plane goes down in the midst of tragedy and confusion, the world's attention turns to one thing: the search for the black box. It's a name that conjures images of a mysterious, indestructible vault holding the secrets of a flight's final moments. But here's your first fun fact. The black box isn't black at all. It's painted bright, almost fluorescent orange, to make it as easy as possible to find among the wreckage. And it's not just one box, it's two. These devices are the silent digital detectives of the skies, and today we're prying them open to see how they work. So, what are these two orange boxes doing tucked away in the tail of an aircraft? They are the Cockpit Voice Recorder, or CVR, and the Flight Data Recorder, the FDR. Think of them as the aircraft's ears and its memory. First, the Cockpit Voice Recorder. This device is a microphone for the cockpit. It captures every word spoken between the pilots, every radio call to air traffic control, but also every ambient sound. The click of a switch, a sudden alarm, even the specific rumble of an engine changing pitch. Early CVRs only recorded for 30 minutes, but today's models can hold up to 25 hours of audio. This is crucial because a problem might start to show subtle signs long before the final critical moments. Then you have its partner, the Flight Data Recorder. This is the objective storyteller. While regulations say it must track at least 88 different parameters on a new plane, things like altitude, airspeed, and heading, a modern FDR, like the one on an Airbus A350, can track around 3,500 parameters. It records a constant stream of data that allows investigators to create a stunningly detailed, second-by-second 3D animation of the entire flight, showing exactly what every system on the plane was doing. Now, for these recorders to be useful, they have to survive things that, by definition, the aircraft itself did not. And the engineering behind them is incredible. The memory units are protected by a fortress. We're talking a layer of aluminum, followed by high-temperature insulation, all wrapped in a super strong shell of stainless steel or titanium. How strong? Well, they are tested to survive an impact force of 3,400 gigaseconds. That's 3,400 times the force of gravity. They have to withstand being in a fire at 1,100 degrees Celsius for an hour. And if the crash is over water, they're built to handle the crushing pressure at 20,000 feet below the surface. They are truly built to survive the unthinkable. So how do we find them? For crashes over water, each recorder has an underwater locator beacon, or a pinger. Once it hits the water, this beacon starts emitting an acoustic pulse that can be detected from up to 14,000 feet deep. It will keep pinging for up to 90 days. Once found, they're rushed to a specialized lab. The data extraction is a painstaking process. If they've been in salt water, they're kept in fresh water to stop corrosion. Any moisture is carefully baked out in a vacuum oven. It can take a week just to get a clear transcript from the voice recorder, and months to fully analyze all the data. This data has been the key to solving some of aviation's biggest mysteries. Take Air France Flight 447 in 2009. It vanished over the Atlantic, and it took 2 years to find the recorders on the deep ocean floor. They revealed that ice had blocked the plane's speed sensors. This caused the autopilot to disconnect, and in the confusion, the pilots accidentally put the plane into a stall it never recovered from. Because of that data, pilot training for high-altitude stalls was completely overhauled worldwide. But the recorders don't just tell stories of tragedy. They also confirm moments of incredible skill. That same year, 2009, gave us the miracle on the Hudson. After a bird strike took out both engines, U.S. Airways Flight 1549 landed on the Hudson River with no loss of life. The Cockpit Voice Recorder captured the calm, professional teamwork between Captain Sully Sullenberger and First Officer Jeffrey Skiles. Their communication is now a textbook example of crisis management. So what's next for the orange box? The technology is always evolving. 25-hour voice recorders are becoming the new standard. And to avoid those difficult deep-sea searches, engineers have developed deployable recorders. In a crash, this device is ejected from the tail, floats, and transmits its location. But the holy grail is real-time data streaming. Imagine if a plane's critical flight data was constantly being streamed via satellite to the ground. Investigators would have the information instantly. No search would be needed. This could even allow for real-time assistance to a flight in distress. It's a complex challenge, but it's the future. From their bright orange shells to the silent, invaluable data they protect, black boxes are a cornerstone of aviation safety. They give a voice to a flight's final moments, ensuring that every tragedy provides lessons to build a safer future in the skies for all of us. Thanks for listening to G Fun Facts Online.